Thank you, Dean, for introduction every morning to everybody. I would like to have your attention, and I would like to make introduction to the tissue culture for 21st century forest program, and now I'm going to talk already about program. But I will start with acknowledging, because you know those people who have been involved in bidding, they know that there is a very long path since bidding will become reality and we have program. Therefore, I have started the first brainstorming with my science leader, Heidi. We were, both of us, very, very excited. But then we have known that we have to have support. And I really would like to acknowledge Russell Dale for giving us from the beginning very, very strong support, as well all industry partners who've been involved in brainstorming with us and who prepared the proposal. And the final shape of the proposal was done with Ellison. Therefore, thanks to all people from Scion, from industry, from Forest Growers Research, that project will, or proposal will become a project. Okay. What is this new program about? This new program is focusing on making a step change in deployment of allied radiata pine germplasm. It is a priority which has been identified in the Forest Growers Levy Trust Science and Innovation Strategy. What we are aiming to do, we are aiming to use bioreactors, fluidic systems, and automation during the process of somatic embryogenesis. We are lucky because we've been able to assemble a very substantial and very talented team, or according to us, to do this with oversight by industry. We believe the potential value which this project could bring is over 1.3 billion per annum. And our job is to get this to proof of concept by 2026 and implement it soon after. What are the problems we seek to solve? Forest industry has made a substantial investment into radiata pine breeding programs over 50 years. But, there is all the time but, to really be able to gain these gains in deployment, there is still a delay, and we are talking about 24 years. However, the gains in productivity, wood quality, and disease resistance are impressive. And therefore, deployment being fast, agile, and cost-effective was never more important than it is now in the face of increasing commercial and environmental pressures. If you look to this picture, what you are able to see that in the upper part, you have the classical breeding program based on seed orchards, and then propagation of plant material in nursery, and then field testing, which is usually with radiata pine over 17 years. If you look to the bottom part of the picture, we are predicting that with employment of genetic selection and doing some first screenings in nursery, we would be able to speed up deployment of really high quality clonal material in 9 years. This is what we dream about. How we would like to tackle this challenge? That we would like to move from traditional petri dishes based, which is now very common procedure in tissue culture techniques. We would like to really move to the high techniques using bioreactors. We would like to use also fluidic system for sorting embryos, as well a germination platform. Therefore, if we are really dreaming, we are in the beginning of this project, what our future should look like, or how future of somatic embryogenesis should look like, we are dreaming about somatic embryogenesis factory, which is going to be effective and efficient the production of rooting plantlets. But however, all the time when you start with somatic embryogenesis of conifers, you have to have high quality parents, you have to have high quality seed material, and then using bioreactors, we would be able to speed up the proliferation cycle, maturation cycle. We are dreaming about using automated harvest system, a fluidic system, which help us to sort out somatic embryos which are already mature. And those which are in proper conditions, speaking about their morphological and physiological maturity, they will be transferred into the germination and planting system. Therefore, our final product, which is going to be sold into nurseries, are going to be microplugs, where some small seedlings are going to be growing. To allow these seedlings, these small embryoes, to be really resilient and to have good path in nursery, we are planning to work also with endophytes, and I would like to acknowledge Helen for her introduction to biostimulants and to trichoderma. This is going to be also happening during this project, but in the a little bit later stages. Which team is going to deliver this? That we have a very strong international capability and their investments in this area. We have also very huge background knowledge which was developed in New Zealand. As well, we have huge knowledge of industry from New Zealand. The upper part of logos are those who are financially involved. It is Forest Growers Levy Trust, Forest Growers Research, and then Ministry of Business, Innovation and Employment. Scion is the key research partner, but Scion is also contributing financially to this project. Then from research collaborators, the key partners is Georgia Tech University from United States. Then they are going to be working with us in the field of bioreactors, in the field of fluidic systems and germination platform. Lucke, Finnish Forest Research Institute, they are going to be collaborating with us in the field of germination, understanding the basic aspects of germination. Otago University is going to be involved in the research oriented towards understanding oxidative stress, which is going to be the key factor when we will be dealing with bioreactors and cells growing in bioreactors. And then Lincoln Agritech is involved in work with trichoderma, as well Lincoln University. From our industry key partners, it is Arborgene. I am not going to name all of them. What I more would like to say, that I've been already working with many of these people representing these organizations, and thanks to this conference, I was able to know even more. Therefore, these are our key partners, and I am really looking forward working with all of you. What we think how success look like, we really think that varietal deployment in conjunction with genomics will reduce the deployment by 15 years. We strongly believe that we will build a capability in the area critical for New Zealand to deliver on our forestry ambitions. We strongly believe that we are also creating also a platform with application to other tree species, and future-proofing forestry deliver on the right tree agenda, respond to environmental and commercial pressures. I hope that we will be meeting with industry and stakeholders groups as we progress, and we shall be reporting back to you annually. This is just the start of the project. I really would like to acknowledge also Russell Barton, who has been appointed as a project manager for this project, and he is helping us to start and to go in the good direction. Thank you very much for your time.